So today we are going through influence of blast furnace parameter on coke consumption and productivity. So we can start with the influence of blast furnace parameters on coke consumption and productivity. As you all know, in iron making, coke is both a fuel and a reducing agent. Optimizing coke consumption is essential not only for cost saving but also for sustainability. In this video, we will explore how different operating parameters impact coke rate and productivity, and how a systematic evaluation can drive blast furnace efficiency. Now coming to a systematic approach to assessing parameters. Now let us begin with approach, a systematic methodology to assess coke consumption was developed in the early 1980s. This model has since evolved using both analytical and experimental data. The core technique used in factorial analysis, comparing different operational periods to understand how parameters shift influence coke uses and furnace output. This approach ensures that improve or we can say improvements are backed up by data, not just by coming to the categorization of factors. Then we can say the parameters affecting coke consumption are broadly classified into three groups. First, batch parameters. These include iron and slag content, coke strength, and impurity levels such as ash and sulfur. Second, gas and blast parameter such as blast temperature, oxygen enrichment, moisture content, and alternative fuel like natural gas. The third, organizational factors like downtime, idling, and consistency in batch charging and product discharge. Now, each group plays a distinct role in blast furnace operation and require tailored control strategy. Now, key finding on gas and blast parameters. As you can see, we will have a look at gas and blast parameter in more detail. Increasing blast temperature directly reduces coke consumption by around 0.14% to 0.30% for every 100 degrees centigrade rise, depending on oxygen content. Now, oxygen enrichment also lowers coke rate, but only when supported by hydrocarbon fuel injection. Without that, enrichment alone may cause overconsumption. Substitution with fuel like natural gas is effective. 1 cubic meter of natural gas can replace nearly 1 kilogram of coke under optimized conditions. This finding helps operators make informed adjustment based on furnace behavior. Now, as per key finding on organizational factors, we can say that the human and organizational aspect here, every 1% reduction in downtime can raise productivity by 1.5%. That's a significant operational gain. Regularity in operations, especially specifically uniform batch charging and timely discharge, helps maintain a stable thermal profile in the furnace. Irregularities introduce inefficiencies, cause higher coke consumption, and uneven productivity. In short, we can say that discipline in process execution is just as important as technical improvement. Now, coming to the general principle, we can say that the study proposes three powerful principles. One is damping principle. The closer you are to optimum furnace condition, the smaller the impact of further changes. Combination principle, what it says that sometimes combining opposing measures can produce a net positive effect. For example, higher blast temperature with moisture control. Principle of limiting states. There is a point beyond which further improvement yield diminishing returns. So, understanding these principles helps in making strategic, not just tactical interventions. So now coming to the practical implication, which is most important. So we can say that a comprehensive reference table, referred to as a table 1, list how various parameters impact coke consumption and productivity. This table isn't theoretical, it's based on empirical plant data and validated through detailed analysis. Operators can use this as a real world guide to diagnose performance issues or plan optimization initiatives. It's a valuable tool for continuous improvement in daily blast furnace operation. So, gentlemen, in conclusion, we can say that this systematic data driven approach to assessing blast furnace parameter has stood the test of time. The refined standard offers a reliable foundation for ongoing technological upgrades. Whether you are managing a furnace or designing processes improvements, these insights can help you optimize both coke consumption and productivity. Thank you.